How are you? So today we are going to learn exponents and powers chapter 4, right? So first we'll see, first we'll observe this video to understand the meaning of powers and exponents.
What happens if we keep on adding 2 to itself? This is 2. This is 2 added twice. This is 2 added 3 times. And so on. And this is 2 added 10 times. We know that this can be written as 2 into 1, 2 into 2, 2 into 3, and 2 into 10. So similarly, 2 added 50 times can be written as 2 into 50, and 2 added to itself 100 times can be written as 2 into 100. And we know that this operation is multiplication. So multiplication denotes repeated addition. But what happens if we keep on multiplying 2 to itself? This is 2. 2 multiplied twice. 2 multiplied 3 times. This is 2 multiplied 10 times. Now imagine how much time and space will be required if we want to multiply 2 50 times or say 100 times. And it would also create a lot of confusion. So mathematicians came up with a shorthand notation for such large numbers. So 2 multiplied with itself 3 times is written in this manner. That is 2, and 3 is written as a superscript of 2. Similarly, 2 multiplied to itself 50 times is written in this manner. That is 50 is written as a superscript of 2. 2 multiplied to itself 100 times is written in this manner. 100 is written as a superscript of 2. And such numbers are called exponential numbers. So exponential denotes repeated multiplication. Just like multiplication denotes repeated addition, exponentials denote repeated multiplication. So this is an exponential number. Now, in this case, we see that the number being multiplied is 2. 2 is being multiplied. So this number, which is being multiplied with itself, is called base. So 2 is the base here. And how many times is 2 being multiplied? 1, 2, 3. 2 is being multiplied 3 times. So this 3 is called the exponent or the index or power. Exponent, index or power. So 2, that is the number which is being multiplied, is called the base, and the number of times it is being multiplied is called the exponent, index or power. So this is another exponential number. 3 is the base here. 4 is the exponent. Remember that this is not 3 into 4. This is not 3 into 4. This is 3 multiplied 4 times. So 3 multiplied with itself 4 times. We read it as 3 to the power 4, 3 to the power 4, or 3 raised to the power 4, or 3 to the 4th power. So we can read it in any manner we want. 3 to the power 4, 3 raised to the power 4, or 3 to the 4th power. So now can you find this? Well, this is 8 to the power 2. 8 is the base here. So 8 is the number which is being multiplied. And how many times it is multiplied? It is multiplied 2 times. So this is 8 into 8. 8 multiplied 2 times. And 8 into 8 is 64. So this is equal to 64. So in general, any number a multiplied n times can be written as a to the power n. A is the base, n is the exponent. So a to the power n denotes a being multiplied n times, and we read it as a to the power n, a raised to the power n, or a to the nth power. We can read it in any manner as we want. So can you represent this in exponential form? Well, we see that 5 is being multiplied. So first thing is 5 is the base. Next thing is that we need to find the exponent. Exponent will be the number of times 5 is multiplied. So let us see how many number of times is 5 multiplied. 1, 2, 3, 4, 5, 6, 7. So 5 is multiplied 7 times. So this is 5 to the power 7, or 5 raised to the power 7. This is the correct representation of this number. Now you might be wondering, what is the use of exponents? Consider the mass of sun. The sun has a mass of these many kgs. Now imagine how difficult it would be for scientists to read, write, and moreover remember such huge numbers. Wouldn't it be convenient for them if they represent it like this? Well, this is 1988 into this huge number, and this huge number is 10 multiplied by itself 27 times. 10 multiplied by itself 27 times can be written as 10 to the power 27, and we have 1988 from here. So the mass of sun, which is this huge number, can be represented in a short form using exponents like this. 1988 into 10 to the power 27 kgs. For instance, a light year, which is the distance light travels in 1 year, is 9461000000000 meters. Now wouldn't it be better if I tell you that it is 9461 into 10 to the power 12 meters? Yes, it is much more convenient. And that is why exponents were introduced. So do not confuse exponential numbers with multiplication. With exponents, the numbers increase much faster, as you can see here. And now, let me tell you an interesting story. There's a famous legend about the origin of chess. When the inventor of the game showed it to an emperor in India, the emperor was very impressed by the new game. He told the man to ask him for some reward. What the man had asked was some grains of rice. He said that 1 grain of rice be placed on the first square of the chessboard, 2 grains on the next square, 4 on the next, 8 on the next, and so on for all 64 squares, with each square having double the number of grains as the square before. The emperor was amazed at the modest demand of the man and immediately agreed. And what happened next is astonishing. By the time the 17th square was reached, the table was filled up. By the 26th square, the entire room was full of rice. And when 42 squares were accounted for, the entire palace was filled with rice. In fact, the reward would add up to an astronomical sum far greater than all the rice that could conceivably be produced in many, many centuries. Such is the magic of exponentials.
Okay, I hope you enjoy this video and you have understood the concept of exponent and meaning of exponent, right? Then some more concept we'll see. So what you understood from video, what is exponent? Exponential notation is useful in situation where the same number is multiplied repeatedly. In video also you have observed same things. So here if you will observe that it's 5 to the power 6. So here 5 is called base and 6 is called exponent. The number being multiplied is the base and exponent tells you how many times the base is multiplied, right? So here 3 into 3 is 9. In exponential form, if you want to write, then it will be 3 squared, and you will read like 3 squared or 3 raised to the power 2. So here 3 into 3 into 3, here 3 to the power 3. That means 3 raised to the power 3 or 3 to the power 3 we can write. Okay. Now exponent fact. Some important fact we'll observe in this chapter, that is any non-zero number to the power 0 will be always 1, where a is an integer except 0. A should not be 0. Then a to the power 1 will be a, right? The base in an exponential form can also be a negative integer. So sometime in power you will get negative number also, right? Okay. Now see negative exponents. A number a raised to the negative n power is equal to 1 divided by a raised to the positive n power. That is a to the power minus n will be 1 by a to the power n. The fraction raised to the negative power is equal to the reciprocal of the fraction raised to the positive power. So a by b to the power minus n will be b by a to the power n. So you will remember this. Okay. Now next, expanded form of a number. Okay. So suppose 452.369 can be written as 4 into 100 plus 5 into 10 plus 2 into 1 plus 3 into 1 by 10 plus 6 into 1 by 100 plus 9 into 1 by 1000. So in power, if you want to write, it will be 4 into 10 to the power 2, because here 2 0. So it will be 10 to the power 2 plus here 10 to the power 1. Here 10 to the power 0, because 1 we are getting. So 10 to the power 0 we can write. 1 by 10 can be written as 10 to the power minus 1. 1 by 100 can be written as 10 to the power minus 2. 1 by 1000 can be written as 10 to the power minus 3. So this is expanded form, right? Now laws of exponent. Okay, so what is laws of exponent? So here total 7 laws you will get. Multiplying power. So if you multiplying powers with the same base, keep the base and add the exponent. So x to the, if base are same, then power will be added. So this example you can see how it will work. Now in case of division, if base are same, then power will be subtracted. Now power of power, that means x to the power m to the power n, x to the power mn. So this example you can see. Now next law will be xy to the power n equals to x to the power n into y to the power n. Okay, and if x to the power n into y to the power n, then you can combine and you can keep xy in bracket and it will be to the power n. In division, same case, x by y to the power n, x to the power n divided by y to the power n. So already 5 laws we got. Now next, x to the power 0 will be 1. Any non-zero integer like 5 to the power 0, any, even it is not integer, if any fraction also, any rational number also to the power 0, then also it will be 1. Very useful for laws it is. Now, if in power you are getting negative number, then you have to take its reciprocal, right? So now observe the pattern. 30 can be written as 3 into 10. 300 can be written as 3 into 100, 3 into 1000. It means we can write 100 like that, 10 into 10. Okay, what is 10 into 10 in the exponential form? That is 10 to the power 2. So 30 can be written as 3 into 10. 300 can be written as 3 into 100, that is 3 into 10 to the power 2. 3000 can be written as 3 into 10 to the power 3. Now we learn the scientific notation, like big number if you'll get. Like here, how many zero? See, 2, 4, 6, 8. 8 0 can be written as 3 into 10 to the power 8. 75. So count here a 0. 15 0 you will observe. So 10 to the power 15 we can write. Now we can write 75 as 7.5. Right? We can write 7.5, but what? If you move this point left side 1 digit, then what will happen? It will be 10. Okay, so before that what you got? Just observe this number. Here 10 to the power 15. Now 7.5 if you write, then one more 0 will come. So it is 10 to the power 16. Right? This type of number is called standard form of number. Such a form of a number in which the number has only 1 digit in the integral part with a power of 10 is called a standard form of a number. Since it is used by scientists to write very large and very small number conveniently, we also call it is a scientific notation of number. Now that is a standard form. So here we learn the number is expressed in a standard form by writing it as a power of 10 such that there is only 1 digit to the left of the decimal point. Okay, left of the decimal point. Try to understand. Only 1 digit you will get. If the number is greater than 10, then the power of 10 is positive and is equal to the number of place the decimal point moves to the left. If the number is less than 10, it's very small number, then the number of 10 is negative and is equal to the number of places the decimal point moves to the right. Like here, just try to understand. Point is at the end. So how many places you have to move to make it a standard form? We have to move 7 steps. Just count it. 1, 2, 3, 4, 5, 6, 7. So we can write 4.56. Last this 0, it is meaningless if we'll put point. So we'll not write into 10 to the power 7. But here it is, this number is less than what? 10. So we have to move right side. So how many places right side we have to move? 1, 2, 3, 4, 5. So 4.56 into 10 to the power minus 5. Negative power you have to put. Now working with big number. So like that, we can work big numbers and you can express as standard form. Now look at this number which is a standard form 6.3 10 to the power 5. Exactly one digit before the point only one digit. The power is positive or negative whole number. Here either positive you will get or negative you will get, right? Okay, understood? Okay, so I hope you understood. So now observe next slide like that. Write this in usual form. Now it is standard form is given, and if you have to write in usual form, then 10 to the power 4, then point you will shift right side 4 place. So here only 2 digit, so 20 you will put. After that you will write its answer. Like here 10 to the power 2, so 147. 10 to the power 6, so here 2 digit already you have, 40 you will put. Here 10 to the power 0, so 1.3. 10 to the power 3, so here 30 will come. Here 10 to the power 1, so one place you will shift. So this is the usual form. Now usual form of a number to standard form. Okay, same things here. Last at the end point we have to shift left side. Then if you will shift 5 place left, then 10 to the power 5. Okay, so like that we can calculate and we can write in standard form. Write this in standard form. So same things, how many places you have to move left side? 3 places. That's why 10 to the power 3. So some examples are given, just you can observe. Now number less than 1, less than 1. So if number less than 1, then consider the number 2.03 into 10 to the power minus 3. Now here power is negative. Try to understand. So if negative, then you have to shift point left side. So here one digit, but 3 places you have to move left side. So 2 more 0 you will put. So like that we can convert in usual form. Write this in usual form. Similarly 10 to the power minus 4. So left side 3 more 0 you have to write, and then 0.001107 you will get. Now usual form to standard form. Now suppose usual form is given, then right side you are moving. So 1, 2, 3 place you will move right side, 10 to the power minus 3. Okay, so write this in the standard form. If the standard form right side 3 place, so 10 to the power minus 3 you will put. Some examples are given. Okay, so you can do it. Okay, now our this 4.1 exercise will solve, right? Okay, so just observe the question of 4.1. Okay, so now first question. What is the first question? Okay, we have to see full screen. Now here just see first question. Find the value of the following: 3 to the power minus 4. So 3 to the power minus 4. This is the first question. So one by one we'll solve the question. So start exercise 4.1. Now answer 1. First question is what we are getting. First question, that is 3 to the power minus 4. Find the value of the following. Its value we have to find. 3 to the power minus 4. 3 to the power minus 4. Okay. So can be written as, first remove negative from power. It will be 3 to the power 4. So can be written as 1 by 3 into 3 into 3 into 3. Okay. So if we multiply this, then what you will get? 1 by 81. So one more questions we'll do. Last one, 1 by 10 to the power minus 4. 1 by 10 to the power minus 4. First remove negative from power, then its reciprocal will take, then power will be positive. So 10, how many times you have to multiply? 4 times. That means how many 0 will come? 4 0 will come. So 2 I have done, and 2 you will solve, right? Now next question, number 2. Number 2, find the multiplicative inverse of each of the following. 7 to the power minus what? 3. 7 to the power minus 3. Question number, answer 2. First question. So first question, what we are getting? 7 to the power minus 3. 7 to the power minus 3. We have to write multiplicative inverse. Multiplicative inverse already we did in chapter 1. So what we got? Its reciprocal we have to take. Multiplicative inverse means reciprocal of the given number. Now remove negative from power, then you have to take its reciprocal. So 3 to the power 3. Now 7 into 7 into 7. You can multiply or leave like that. Here they are not saying in which form you will write. So leave like that. Then next question, 1 by 2 to the power 5. So we have to write multiplicative inverse of 1 by 2 to the power 5. Okay. So fourth one, multiplicative inverse will be, here number was, what was the number? Just check once again. 1 by 2 to the power 5. 1 by 2 to the power 5. This was the given number. So its multiplicative inverse will be 2 to the power 5. So 2 to the power 5 we can write. 5 times you can multiply or leave like that. You will get full marks. Okay. Now question number 3. Write the expanded form of the following number using exponent. The one I am doing 632.542. 632.542. This is the first question. Expanded form. In expanded form, if you want to write, then 6 into 100. 100 means 10 to the power 2 plus 3 into 10. 10 means 10 to the power 1 2 into 1 means 10 to the power 0 plus. Now after decimal, power will be 10 to the power will be negative. So 10 to the power minus 1, right? Plus 4 into 10 to the power minus 2 plus 2 into 10 to the power 10 to the power minus 3. I hope you understood. So one more questions we'll do D. So 0.1235. 1235. Fourth one. 0.1235. So left side only 0 is given, right? So in expanded form, if you want to write, then it is 1 into 10 to the power minus 1 plus 2 into 10 to the power minus 2 plus 3 into 10 to the power minus 3 plus 5 into 10 to the power minus 4. Right? This was the number 1, 1, 3, 1, 2, 3, 5. Okay. So we have completed 3 questions. Now question number 4. Here 2 questions. I'm showing to you 2 to the power minus 1 plus 3 to the power minus 1 plus 4 to the power minus 1. Simplify this question. So 2, 3, 4. So answer now. Answer for first question. So first question is 2 to the power minus 1, 3 to the power minus 1. So 2 to the power minus 1, 3 to the power minus 1 plus 4 to the power minus 1. Okay, right? This are here you have to simplify. So we know that from power, if you remove negative sign, then we have to put 1 by 2. From here, if you remove, then 1 by 3. From here, if you remove, then 1 by 4. Got my point? After that, okay, if you want to add, either you will take LCM or like that you can do. 2 into 3, how much? 6. And cross multiply, 3 plus 2. That is one method to add fractional number, 1 by 4. So it is 5 by 6 plus 1 by 4. Again same rule I am using. Multiply 6 and 4. 24 cross multiply 20 plus 6. Then we are getting 26 by 24. Cut by 2. 13. And here 12. So we are getting 13 upon 12. I hope you understood. Now answer for fourth question. Second and third I am keeping for you for practice. Now fourth question. Now see the fourth question. So here 3 to the power minus 1 plus 4 to the power minus 1 to the power minus 1. So 3 to the power minus 1 plus 4 to the power minus 1 to the power minus 1. Simply use law of exponent. Remove negative from power. So here 1 by 3 we can write. Here 1 by 4 we can write. And this minus sign keep as it is. Later we'll do. Add these two. Multiply this denominator. So 12. Cross multiply, then 4 plus 3. This is the easiest way to add or subtract fractional number, and you will not make mistake also. Some student I observe facing problem, okay, by taking LCM. So by taking LCM also we can add, and like that also we can add. So 7 upon 12 to the power minus 1. So we are getting 12 upon 7. So this is our answer. So I hope you understood. Okay. Now see answer 5. First question. So question number 5. Simplify and write each of the following in exponential form with a positive exponent. So minus 5 to the power. Just check the question properly. What is the question? Minus 5 to the power 4 and 125 to the power minus 3. Minus 5 to the power 4 and 125 to the power minus 3, I think. Yeah, minus 3. Minus 3. So here negative to the power even number will be positive. So we can write this is 5 to the power 4. Understood? Because minus into minus plus, minus into minus into minus will be minus, minus into minus into minus into minus. 4 minus, if you will multiply, then positive you will get. And here 125 can be written as, if you factorize, it is 5 to the power 3 to the power minus 3. Now power to the power. So power will be multiplied according to law. 3 into minus 3 minus 9. Now base are same. In multiplication power will be added. So 4 and minus 9 plus minus 9. So it will be minus 9. So we are getting 5 to the power minus 5. But we have to write in positive exponents. So we can write 5 to the power 5. It's reciprocal. We have to take. So understood? One more question. Answer 5. Fourth question I'm showing you. Just check here. What is given? 3 to the power minus 1 divided by 3 to the power 4 equals to, what is it? Just check it. Okay. It is 3 to the power minus 7 divided by 3 to the power 4 equals to 3 to the power 5. So little bit not clear properly. So just observe. Okay. So I'm taking 3 to the power minus 7 divided by 3 to the power 4 into 3 to the power 5. Okay. So 3 to the power minus 7 divided by 3 to the power minus 7 divided by 3 to the power, what we are observing here, 3 to the power 4, and this is 3 to the power 5. 3 to the power 4 into 3 to the power 5. If any other number in power, according to that you can write. So base same. In division, power will be subtracted. So minus 7 are here minus 4. So power will be subtracted. Keep in bracket into 3 to the power 5. So we are getting 3 to the power minus 11 into 3 to the power 5. So 3 to the power minus 11 plus 5, then 3 to the power minus 6. So it is